So before spring break, we had been working with fractions and decomposing them. We just heard that word decompose in our science. What does decompose mean? What does it mean, Christopher?
Like break down in different pieces or like to
Yeah. Yes, to break it down into smaller pieces. So I have a tape diagram up on the board projected. What is the total or the whole in this tape diagram? What's the value of the whole, Olivia?
15.
How do you know that the value of the whole is 15?
Because there's a 15 on top of it.
Exactly. That 15 up top gives us the value of the whole. What about the bracket that's underneath the 15? Is that important, Jacob?
Yes.
Why?
Because it shows that
And that shows me what parts make up that 15. And in this particular model, the 15 is the whole entire thing. How many parts is this divided into? 3 equal parts, okay? So on your work mat, I want you to write the value of this unit that's shown on the tape diagram as a division problem. I want you to write a division problem that would match that diagram. What's the total that I started with, Owen? 15. So I would need to write 15. And that's divided into how many equal parts, Dylan?
3.
3 equal parts. So I would have 15 divided by 3. What's the value of each part, Olivia?
5.
How did you know that?
Because 5 times 3 is 15.
Exactly. 5 times 3 equals 15. So now I want you to write that multiplication sentence. Write that whole as a multiplication equation. What would that look like, Ansley?
5 times 3 is 15.
Exactly.
And 3 times 5 equals 15.
Yes, we have 3 groups. Each group has a value of 5, so 5 times 3 equals 15. How could we write that as repeated addition? Write that same value as repeated addition. What's that going to look like, Jacob?
We're going to write 5 3 times.
Yeah, 5 plus 5 plus 5 equals what? 15. And how is 15 represented in our diagram?
That's the whole.
That's the whole, exactly. So how many different ways did we express or write equations to match this diagram, Christopher?
3.
We made 3 different equations that match this picture. We wrote a division equation, a multiplication equation, and repeated addition. Okay, I want you to erase your work map, and I'm going to show you another one. Erase your work map. This time, what's the whole or the total?
8.
8. How many parts do I have?
2.
I want you to write the 3 equations that would match this. Then get one that does. Then get one that does. Okay, you should have 3 equations. What's the division equation, Cash?
8 divided by 2 equals 4.
How did you know that it was going to be 8 divided by 2?
Because 8's on the top and then there's 2 squares.
Very good. We have a total, or the whole makes 8. And it's divided into 2 parts. And if I divide 8 into 2 groups, each one of those parts would have a value of 4. How did you write that as repeated addition, Amy? 4 plus 4 equals what?
8.
Very good. I had one part that had a value of 4, plus another part with a value of 4. And if we total those up, the sum is 8. What was your multiplication equation, Harper?
4 times 2 equals 8.
Perfect. 4 times 2 equals 8. All right, erase. All right, here's another. I want you to write the 3 equations that would match this diagram. What would my division equation be, Brayley?
20 plus 20 plus 20 plus 20.
The division.
Oh. 20 divided by 5 equals 4.
How did you know it would be 20 divided by 5?
Because, there's 5 down there and you're dividing that 20 into 5.
Up on top of the bracket, it shows us 20. That's the total. And underneath that bracket, there are 1, 2, 3, 4, 5 equal parts. Do you think it's important that those parts are equal? Yeah, because if they weren't equal or the same size, then they would not have the same value. So Brayley's correct. 20 divided by 5 is the division. How do I complete that equation? 20 divided by 5 equals what, Brayley?
20 equals 4.
Equals 4. So each one of those boxes or sections has a value of 4. How did you write that as repeated addition, Alexis?
5 plus 5 plus 5 plus 5.
No, does each one of those have a value of 5?
4 plus 4 plus 4 plus 4 plus 4.
Very good. It's going to be 4 plus 4 plus 4 plus 4 plus 4 equals 20. Why could I not do 5 plus 5 plus 5 plus 5?
That'd be 24.
Because it would be what? I don't know. If I did 5 plus 5 plus 5 plus 5,
It would be 20.
that would be 20 still, but why does that not match?
Because that's not the answer. It doesn't have 4 in it.
Because, Olivia, why?
It doesn't have 4 in it.
But I added 5 4 times.
Oh.
So why does that not match the diagram that we have projected?
But there's not 4 groups.
Because there's not 4 equal pieces or 4 groups. You're exactly right. There's 5. So even though that equation is true, that equation does not match our model. What would my multiplication sentence be that matches that model, Caden?
5 times 4 equals 20.
5 times 4 equals 20. Very good. All right, erase. Okay, here's your next one. Write your 3 equations. Justice, what's my division equation? Mm-hmm. Very good. My total is 12. And I'm dividing that into 2 equal groups. 12 divided by 2 equals 6. What's my multiplication equation going to be, Ansley?
6 times 2 equals 12.
Very good. 6 times 2 equals 12. Each one of those sections has a value of 6, and I have 2 of those. What's the repeated addition going to be, Olivia?
6 plus 6 equals 12.
Perfect. 6 plus 6 equals 12. All right. Erase. Okay, here's your next one. Cash, what's the division?
8 divided by 4 equals 2.
8 divided by 4 equals 2. My total is 8 underneath the bracket. It's split into 4 equal pieces. And so we know 8 divided by 4 is equal to 2. Amy, what's the repeated addition?
4 plus 4.
Do I have 4 plus 4 shown in that? Very good. I have 2 plus 2 plus 2 plus 2. And that equals what? 8. If it's an equation, it has to have an equal sign and something that has the same value on both sides. How would I write that as a multiplication equation, Dylan?
4 times 2 or 2 times 4?
Okay. If I make that an equation, what else do I have to have besides 2 times 4?
Equals 8.
Equals 8. I have to have the equal sign and an equal value on both sides. All right, erase quickly. Here's your next one. Owen, what's my division sentence?
I haven't got it.
Okay, well, look at it and tell me what it would be. What's the total?
21.
21. So I have a value or a whole of 21. And I'm dividing that into how many equal pieces?
3.
3.
And that would be 7.
Very good. I'm doing 21 divided by 3 equals 7. What would my multiplication sentence look like, Alexis?
3 times 7 equals 21.
Perfect. How would I write that as repeated addition equation, Christopher?
7 plus 7 plus 7 equals 21.
Very good. All right. Here's your last one. What's my division equation going to be, Caden? 32 divided by 4. I've got 4 equal parts. The total is 32. And what is 32 divided by 4? What is it, Jaden? 8. 32 divided by 4 is 8. How am I going to write that as a multiplication equation, Jacob?
4 times 8 equals 32.
Very good. And how about repeated addition, Ansley?
8 plus 8 plus 8 plus 8.
Very good. Equals 32. So why do you think that we just spent that time looking at a tape diagram and the whole broken into parts? How would that relate to fractions? How would that relate to fractions, Olivia?
Because you find the missing number and put it in there, and that missing number is what's going to equal your whole number.
Okay. Can we use tape diagrams to model fractions?
Yes.
Absolutely. Instead of looking at this example that we have, instead of 32, if I took that 32 off, and I showed that that total was 1, instead of 32, the total here is 1. How many equal pieces is that 1 broken into? How many equal pieces are underneath that bracket? There's still 4 equal pieces, aren't there?
Yes.
1, 2, 3, 4. So I'm taking one whole. I'm still dividing it into 4 equal pieces. What's the value of each one of those pieces? 1 what? 1/4, exactly. So it looks funny, but I could still write that as a division equation. My total is 1. I'm dividing that 1 into 4 equal pieces, and the value of each piece would be 1/4. How could I write that same equation as a multiplication sentence? What's the value of each piece? What did we just say the value was?
30.
If it's broken into 4 equal pieces, then each piece has a value of 1, what?
8.
Whoa, time out.
1 night.
Time out. Stop. Stop, stop. Look at that picture. We're saying that the whole represents 1. And what is it, Cash? 1/4. It's 1 broken into 4 equal pieces. So each piece is worth 1/4. How many 1/4s do we have?
4.
4. 1/4 times 4 equals how much? If I have 4 1/4 size pieces, how much would I have? I've got 1 whole, wouldn't I?
Yes.
Very good. How could I write 1/4 times 4 as repeated addition?
Wait, what?
What are you confused about, Christopher?
Wouldn't it be 1 night?
If I make the total 1 instead of 32,
Oh, wait, never mind.
how How would I write 1/4 times 4 as a sum of unit fractions?
4 plus 4 plus 4 plus 4.
Not 1 plus 4. What's the value of each piece?
1/4.
1/4. So I would have 1/4 plus 1/4 plus 1/4 plus 1/4 equals 1. That's the sum of unit fractions. I could break that down into each piece and I could add them together. Alright, we're going to do something a little bit different now. Alright, look at that picture. What's shaded, Jaden?
1 of them. But I think it'd be 1/4.
It would be 1/4. How do you know it would be 1/4?
Because it takes up one whole entire side. So you just have to put only 2 more lines and it looks exactly like it.
Exactly. I could break that apart. Even though the lines aren't shown, I could break that apart into 4 equal parts. And one of those is shaded. How many circles do you see?
1.
No, I do not. How many circles are there? 1. I have 1 circle. How many parts does the circle have?
4. Well, 1 right now.
But how many equal parts would that be broken into? 4, exactly. And what fraction of that circle is shaded? 1/4 is shaded. What fraction of that circle is not shaded, Olivia?
3/4.
3/4. Very good. All right, let's look at another one. How many rectangles do you see?
3.
3. How many are shaded? 2.
2/3.
So the shaded portion represents 2/3. How could I write that as a sum of unit fractions? If I look at the unit of each piece, what's the value of each part? How many parts is it broken into, Harper?
Thirds.
It's broken into thirds, so each part has a value of how much?
1/3.
1/3, exactly. So I could say 2/3 is equal to 1/3 plus 1/3. Would that be a true statement?
Yes.
Okay. How could I write that addition sentence as multiplication?
This one?
Mm-hmm.
2 take the 3.
Do what?
Wait.
What's each piece?
1/3.
1/3. And how many do I have shaded?
2.
So I would write 1/3 times. How many pieces are shaded?
2.
2. 1/3 times 2 is equal to 2/3. Okay. Oh, I know this is something we haven't really done before. That's why it's very important that you're paying attention and that you're focused in on what we're doing. Okay. This is really, really important that we can look at a diagram and we can make sense of it as a fraction, and then we can convert that to a sum of unit fractions or a multiplication equation. Okay, so everybody take a deep breath, sit up, eyes on the board, and let's think about what we're doing. Here's our next one. All right, this represents 1 whole. On your work mat, I want you to write down the shaded portion. What portion of that is shaded?
3.
What is it, Jaden?
3.
3 what? 3/5. Very good. So I have 3/5 shaded. What is each unit or each part's value? What's the value of each part going to be, Ansley? 1/5. How did you know that?
Because if the fraction 4 was 3/5, then each one means it's 1/5.
Yeah. That one whole that I have represented in that model is broken into 5 equal pieces. So I know that each piece is going to be 1/5. How could I show the shaded portion as a sum of unit fractions, Dylan?
The sum is 3.
How can I show that model with 3/5 shaded? How could I represent that as a sum of unit fractions? What does sum mean?
Total.
The answer to what kind of problem?
Addition.
Addition. So if I'm looking for an equation that is the sum, I know I'm going to be adding. And unit fractions means I'm going to add the value of each piece. So what's the value of each piece? We just talked about that. It's the value of each piece in that fraction. And so what was the value of each piece?
1/5.
1/5. How did she know that the value was 1/5, Owen?
Because there's 5 ones of each.
Exactly. That one whole is broken into 5 equal parts. So now I need to represent that as a sum of unit fractions. I need to add each piece that is shaded. How will I do that, Dylan?
You add 1/5 to 1/5 to 1/5, and you get 3/5.
Very good. 1/5 plus 1/5 plus 1/5 equals 3/5. How could I write that as a multiplication equation? What could I do to write that as multiplication instead of addition?
1 times 3.
1 times 3 would not equal 3/5.
1/5.
What is it, Jacob?
1/5 times 3.
Exactly. My unit or each piece is 1/5. I have 3 1/5 shaded, and that equals 3/5. Okay. Let's make sure we're paying attention. Let's try another.
4/6.
I want you to write down the shaded portion. What portion of that is shaded? Thank you, ma'am. Olivia, what portion is shaded?
4/6.
4/6 is shaded. How did you know that?
Because there's 4 shaded and there's 6 in total.
Very good. I have 4 parts shaded, and there's 6 parts in the whole. So the value of the shaded portion is 4/6. How would I write that as a sum of unit fractions? What is each unit, Owen, or each part?
1/6.
1/6. So if each part is 1/6, how would I show the sum of unit fractions of the shaded portion? What would I add?
4/6.
Each
1/6,
part-
1/6.
Yeah, each part is 1/6 plus another 1/6 plus another 1/6 plus another 1/6 equals 4/6. Okay, how would I write that as multiplication, Harper?
You write that, I haven't got it yet.
What's each part?
1/6.
1/6. Then how many 1/6 do I have shaded?
1/6.
1/6 times 4. I have 4 1/6 size pieces, and that would equal 4/6. What does unit fraction mean? What is a unit? What is it, Scotty?
All.
The unit's the piece. Each piece. Okay, so that the value of the unit in this model is 1/6 because each piece is 1/6 of the whole. Don't get caught up in the vocabulary or the terminology, okay? Unit just means piece. If they're asking for a sum means what?
Total.
The total to what kind of problem?
Addition.
Addition. So the sum means I'm going to add. Unit fractions is the value of each part. So I'm adding each part together. If they ask for a multiplication sentence with the unit fractions, I'm taking each part and I'm multiplying by the total number that are shaded. So let's look at another. What's the unit? What's the unit? Remember, what does unit mean? Each piece. So what's the value of each unit? Each piece has a value of how much, Ansley?
1/6.
1/6. I know that because one piece obviously is going to be 1, and there's 6 in the whole thing. How many 1/6 do I have shaded, Olivia?
5.
I have 5 1/6 shaded. So if I look at that model, I have 5/6. How would I write that as a sum of unit fractions, Christopher?
Unit fraction.
What's the unit fraction?
Unit fraction is 1/6.
Okay. So 1/6 plus what?
4.
Nope.
6.
Sum of unit fractions mean each one of them have to be a unit. So how many 1/6 do you told me the unit fraction is 1/6? How many of those do I need to repeatedly add? 5. 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. I need to add 1/6 5 times. How would I write that as a multiplication equation? The unit fraction is still what?
1/6.
Unit fraction is still 1/6. And how many times do I have 1/6 shaded?
5.
5. 1/6 times 5. Alright, I want you to look at this one. What if I group these two parts to the left of that piece that's not shaded? What's the portion to the left of the white part that's shaded? To the left. This part over here. 2/6. What portion is shaded to the right of that? Oh, I'm sorry. I didn't mean for it to. There we go. What is it? 3/6. So on the left we have 2/6. On the right we have 3/6. Could I write a expression 2/6 plus 3/6
Yes.
equals 5/6?
Yes.
Yeah, absolutely. And if I wanted to show that from my unit fractions, I could group 2 of 1/6 plus 1/6. That makes 2/6. So I could use parentheses to do that. And then I could use parentheses again to show another group of 3/6. Okay, so that's just another way that you could, if you wanted to, group those together. All right, we're going to do a lot more of those this week. But it's really important that we have this terminology down. What is a unit fraction? One piece. The unit is one piece or one part. So if it says a sum of unit fractions, what would the numerator or the top number be? If it's one piece, what would my top number always be in a unit fraction? Scotty, what is it? 1. Always. It will always be 1 in a unit fraction. Okay. If it's a sum of unit fractions, what am I doing to each of those pieces? What does sum tell me to do? What operation? Addition. Sum of unit fractions means to add the value of each unit or each piece. All right, go ahead and erase your work mats.